Hello guys, welcome to Self Help Maths Academy. Today we are going to discuss about the orthogonal projection of the vectors. So let us consider the figure. If you see this here, we have given with usually the projection means what? If we have the two vectors, in short we want to understand. Suppose I have a vector here, say this is my vector y, and I have another vector, say the vector u. Okay, then the projection of let me take little. This is my vector u. I want to understand what is the projection of y. So this is this perpendicular line, if you see, in the direction of u. Okay, if this is what this the projection of this y on u will be this line, the perpendicular line. If you observe this one, in the direction of the vector u. So is it also possible if I have the vector like this? Suppose this is my vector y and say this is my vector u. Okay, then what is the projection here? So here the projection also will be perpendicular. Okay, but the distance, like you can see this distance. Okay, you can see this distance in the direction of u. Okay, so basically the idea is what, in the orthogonal projection, what we are trying to do is, suppose let me give you the explanation with the help of this figure. Here we have given with a non-zero vector, say u in Rn. Okay, we have given with a vector u in Rn, and consider the what we are trying to do is we are trying to decompose a vector y, this vector y in Rn, into the sum of two orthogonal vectors. That is actually orthogonal decomposition. We are decomposing the given vector y into the sum of two vectors, in which one should look like, say for example here u is given, and what we are doing, we are considering the problem, consider the problem of decomposing the vector. We are decomposing a vector, which vector? Y, this vector y in Rn. Okay, into what? Into the sum of two vectors, into the sum of two vectors. Okay, in which what happens, how the two vectors looks like? One vector is, in that one vector is a multiple of u. It is a multiple of u. So if you see, as I told you, this vector which we are renaming it as y. Okay, so this is like alpha times of u. That means it is a multiple of this vector. So as I told you, this is in direction of u, so it is a multiple of the vector u, and the other one is, and the other vector is orthogonal to u. Other vector is orthogonal to u. Okay, so what we have to write now, we are trying to write our vector y as vector y cap plus z, where this y cap is nothing but here, this y cap is nothing but alpha times of u, which is scalar multiple of u, which is in direction of u, and the other vector z, this is the vector which is orthogonal to u. Okay, let me take this as 1. Now where we know that where your y cap is nothing but alpha times of u, for some scalar, say alpha. Okay, and z is the vector orthogonal to u. Z is the vector orthogonal to u. Okay, now what we know, that for given any scalar alpha, for any given scalar alpha, we can write our z as y minus y cap, right? So z as y minus y cap. So this is nothing but what? Y minus y cap is alpha times of u. All right, so that the equation 1 this satisfies. Okay, so now they have given that the vector y minus y cap, this is nothing but z, this is orthogonal to u. When they say orthogonal, that is then y minus y cap is orthogonal to u. Orthogonal to u. When I say orthogonal to u, it is only when it is possible, if and only if your y minus y cap dot with u should be equal to 0. Their inner product, if it is 0, then we say it as orthogonal. So what is y minus y cap? So this is nothing but I can write as y minus alpha times of u dot u. This should be equal to 0. Now let me multiply this. This is y dot u minus alpha. If I take out, it is just u dot u, which is equal to 0. So y dot u is equal to alpha times of u dot u. Okay, so I want alpha. Alpha value is y dot u upon u dot u. Okay, so what we have got now, alpha value as this. So put this alpha value in this equation. What I get, y cap as, because y cap is alpha times of u, this will become y dot u upon u dot u into u. Okay, so here this y cap is called the vector y cap. The vector, this y cap is called, this is called the orthogonal projection of y onto u. So this y cap, we call this as the orthogonal projection of y onto u. Okay, and what is the z here? And the vector z, is called, this is called the component of y, the component of y orthogonal to u. Orthogonal to u. And sometimes your y cap, we usually write this as projection of y onto the, this we write it as projection of y onto this. We also write sometimes as this. So this is nothing but what, y dot u upon u dot u into u. Okay, this is how we define. So the projection of y onto, we read it as projection of y onto the line L. Okay, this is the projection of y onto L. Okay, so we also can read this way, or also we can write it as y cap. So this is the basic idea of projection. Okay, now let us see one example. With the help of example, let us try to understand this. Suppose we are given with, say, let y is equal to, say, 7 6. This is the vector, and we have a vector, say, u is equal to, say, 4 2. Okay, now we have to find out the orthogonal projection of this y onto u. Find the orthogonal projection of y onto u. Okay, onto u. Then we have to write also y as the sum of two orthogonal vectors. Okay, so let us see how do we do it. So we know that what is our y cap? We know that y cap is y dot u upon u dot u into u. We have to find out this orthogonal projection. For this we need y dot u, the inner product of y with u. So that is y transpose into u, which is equal to 7 6 into 4 2, which is equal to 28 plus 12, which is equal to 40. Okay, similarly I want u dot u. So u dot u is 4 2 with 4 2, which is equal to 16 plus 4, that is 20. Okay, so now the orthogonal projection of y, that is, let us substitute the orthogonal projection of y onto u is equal to y dot u upon u dot u into u, which is equal to y dot u is 40, this is 20 times of u, which is what, 2 times of u, that is nothing but 2 into your u is 4 2, which is equal to 8 4. So this is the orthogonal projection of y onto u. And now they ask us to find out the orthogonal component, the component of y orthogonal to u. The component of y orthogonal to u is the component, that is z, the component of y orthogonal to u. Orthogonal to u is given by z, that is nothing but y minus y cap. So we already have our y cap, we know y. let us find out. It is 7 6 minus 8 4. This gives you negative 1 2. So this is your orthogonal component. Okay, now the sum of these two vectors should be y, right? So because we know that we've already just written our y cap as you can write your vector y as the sum of the orthogonal component and the orthogonal component and its projection y. So let us write y as y cap plus z, or you can write y as y cap plus y minus y cap, right? So this is how we can write. So what is our y cap? We already found. Your y cap is 8 4, and what is your orthogonal component, which is negative 1 2. If you just calculate this, this is nothing but what? 7 6. This 7 6 is nothing but your y. So hence this is how we can our calculations are correct, because this gives us to decompose our given vector y into two components. One is the vector which is we can see that this is the vector which is orthogonal to u, and this is the vector which is this vector y cap is the orthogonal projection of u. Okay, so likewise we are going to decompose this into the two particular vectors. All right, I think one I have solved. Let you guys try this and comment your orthogonal projection in the comments. Okay, so if u is given as 8 6, so compute the, they may ask you, they also say that they may ask you to find out the orthogonal projection, or they also say that compute the distance from y into the line u and the origin. So it's all one another same. So find out the orthogonal projection of y onto u, and also find out the orthogonal component, that is z. Okay, so comment your answers in the box. Okay, I think this is all in this video. So maybe in the next video we will discuss the next concept. Till then, take care guys.